Welcome to this new video from HaroUT. I am Marc Dubois and I'm presenting here a video on the soon-to-be released HaroUT library. This is a continuation of the HaroUT daily calculator for ultrasonic phase arrays that was offered by HaroUT a couple of years back. The HaroUT library will offer a set of LabVIEW VIs to set up and acquire phase array data from hardware and to process and display those data. The HaroUT library will be available as a toolkit from the LabVIEW Tools network from National Instruments. The links to the commercial products are provided in the description of this video. The initial experimental setup uses the flat wedge with a 64-element linear probe. The sample is an aluminum block with 1 mm diameter through holes. An overlay indicates the distances and the angles of the holes relative to the approximate entry point of the ultrasonic beam at 0 degree. One hole is at approximately 40 degrees, a little bit more than 10 mm away from the entry point. Another hole is about 20 mm away at nearly 0 degree, and the two other holes are more than 30 mm away at negative 20 and 30 degrees. The VI presented here is an example of an application that could be rapidly developed with the HaroUT library by someone having a minimum experience in LabVIEW. Let's run the VI. A server is started to communicate with the FocusPC server that actually communicates with the FocusPX. Once the communication with the FocusPX is established, the VI can interact with it in real time. Now, let's start the acquisition. At startup, the server loads a .law file containing a default configuration. In the present case, the default configuration does not match the experimental setup. A different .law file can be selected, or new focus laws can be calculated using the HaroUT calculator. Let's just do that. The HaroUT delay calculator was developed as a separate application that is currently available from the LabVIEW Tools network from National Instruments. The calculator will be part of the coming HaroUT library as callable VIs. The calculator is currently configured for a dual probe on a pipe. Let's change the configuration by loading the parameters of the probe used in the experiment. Let's change the sample to a plate. The thickness is not used in the calculation, but let's change it as well. For the focal law, the choices are none, actually only one focal law, sound path, vertical, constant depth, or linear. Let's select sound path. 32 elements for the probe, a depth of 10 mm to focus on the most shallow defect, and focal law scanning from -35 to 35 degrees by 2 degree steps. We can now calculate the delays. The result of the calculation can be plotted for any of the calculated law. Now the delays can be exported either to a .law file or directly to the FocusPX. The new focal laws are uploaded to the FocusPX as the acquisition continues. Looking at the S-scan plot, we can now see the echo from the Wedge sample interface. Let's change the acquisition start time to get rid of this echo. We can see that the shallow defect is well defined, while the other deeper defects are spread out. Let's recalculate new laws for the 20 mm deep defect. With this new set of focus laws, the shallow defect is now more diffuse in the S-scan plot, but the 20 mm deep defect is well defined. The deepest defects are better defined as well. Let's calculate a new set of laws for a depth of 30 mm. The 10 mm deep defect is even more diffuse. The 20 mm deep defect is still well defined but not with as much contrast. This set of laws provide the best definition and contrast for the deepest defects. Now, let's change a flat wedge for a 36 degree wedge. With such a wedge, we might be able to see the 1 mm defects above 30 degrees. When looking at the S-scan, as expected, we don't see any indication. First, a longer time range will be necessary. New focal loss for the new setup must be calculated. Loading the parameters of the probe with the 36-degree wedge. Changing the depth to 40 mm. And the scanning angle from 35 to 75 degrees by step of 1 degree. After the new focus loss have been uploaded to the FocusPX, faint indication can be seen in the S-scan plot. Let's increase the group gain by 20 dB. Voila! The 4 defects can be observed, or at least partly observed. Please provide feedback, comments, suggestions about this video and the HaroUT library using the comment section of this video or directly at harotech.com. Thank you for watching.